Okay, this is our third guide sheet on one-dimensional motion, where we're dealing with the concept of acceleration. First, so far, we've gone through displacement, which is our change in x, and it's the change in position. It's a vector quantity because the direction does matter. We could go to the east, or the west, or the north, or the south. We need to know which way we're going. Velocity is the next step up from that. It is the rate at which we change our position. Rate means to divide by time. It's how quickly we're doing that. So it's the change of position divided by time. It's also a vector quantity. Our next step up will be to look at acceleration, which is going to be involve those other two. Okay, so the instantaneous velocity of an object is the speed that the object has. That's its change of position. And it also has a direction. Since it has two parts, it is a vector quantity. It has both a magnitude, which in this case would be the speed value, and a direction, which is which way it's moving. Now, the idea between accelerating objects, acceleration is the next step up. So it's going to be the rate of change of velocity. So we're going to take your velocity, which is a vector, and we're going to divide it by time. All right. Now, that's also going to be a vector, and it's going to be measured in meters per second, or some other units of velocity and time. Now, since velocity has two parts, its speed and its direction, if we change either of those, we are accelerating. So you have three objects in your car which change the car's velocity. The most obvious is the gas pedal. If you press on that, you should get more power to your engine, therefore you should go faster. That's a change of speed, that's an increase in speed. Now, another accelerator, although many people wouldn't use it as that term, is the brake pedal. Because the brake pedal makes you go slower. Now, acceleration doesn't mean you go faster. It means you change your velocity. So it could mean faster, or it could mean slower, or it could mean the third element, which is your direction. So a third control that you use on the car is the steering wheel. And the steering wheel is also an accelerator. Not because it makes you go faster or slower necessarily, but because it changes your direction. Okay, so anything that makes you go faster, slower, or changes your direction is going to be a device that causes acceleration. To have acceleration, an object either has to get faster, slower, or perhaps a couple of those, change its direction. Okay, an object is accelerating if it is moving. Therefore, it's got nothing to do with how fast it's moving. It can't be acceleration if the velocity is constant, because that says we're moving at the same speed in a given direction. It can be changing of speed, getting faster or slower, or anything that changes our direction, like moving in a circle. Downward may or may not be accelerating. When you drop something, it's probably going to accelerate. But the word downward by itself does not mean that it's accelerating. It has to be a change of speed, faster or slower, and it has to be a change of direction, one or the other of those. So the inverse of that, if it's not accelerating, it should not be changing its speed or its direction. Now, there's actually only one of these that we can say for sure that it's not accelerating. And that's if it's maintaining a constant velocity. Now, you say constant speed, well, it's not getting faster or slower, but how do we know it's not moving in a curve or a circle? An object could go round and round in a circle, but if it's, even though its speed is constant, its direction is constantly changing. So velocity has speed and direction. If velocity is constant, our acceleration has to be 0. Not necessarily if the speed is constant. Okay, so that wraps up our basics of acceleration, we're going to look at acceleration as a rate quantity next and how to calculate it going forward.